Welcome to the third workshop in the Road to Intuition series. First of all, I'd like to thank all of you for signing up for Intuition. And Intuition is just less than a week away, so I hope all of you are super excited for the hackathon. Just so that you know, we have a line of exciting sponsors this year, ranging from Indeed, Goldman Sachs, MSG, Google and GovTech being our platinum and gold sponsors, apart from the other silver and bronze sponsors. So before we start, I'd like to thank NTU OSS for for helping us conduct this workshop in the Road to Intuition series. Um, for those of you who don't know who NTUOSS are, NTUOSS is a tech club in NTU that focuses on various aspects related to the open source code. And this includes holding workshops, having year-long projects, etc. So if you're interested, you can check out the Instagram channels, which will be shared to you at the end. Before we start off, a couple of quick reminders. An attendance form will be shared towards the middle of the workshop. Do remember to fill in the attendance form because the attendance form will be considered as a criteria for swag. By attending all the Road to Intuition workshops, you will be eligible for limited edition swag, which will be which is not the only criteria for swag. The rest of the criteria for swag will be will be told to you on the event day, that is on 26th of February. Apart from this, just a quick reminder, each and every member of the team must sign up for the workshop. So in case you have signed up and your team members have not signed up, must sign up for the Intuition to participate in Intuition. So in case you have signed up and your team member has not signed up for Intuition, do remember to let them know that they have to sign up. Registrations will close midnight of 24th February. So make sure you ask your teammates to sign up if they haven't done so. Apart from this, we are happy to announce that the tracks have been released. So we have 3 tracks, and you can check out the website for Intuition for more details about the tracks. We also have a line of sponsor workshops that are going to be there after the Road to Intuition workshops, and details can be found on the website as well. So without further ado, I'd like to introduce Tejas Rajgopal, who will be conducting the Introduction to Data Science workshop. Quick thing about Tejas. Tejas is the tech director of NTU OSS, and he's currently interning at Continental. So I'm pretty sure you're in good hands, and you have a lot to learn from him. So over to you, Tejas. All the best.
Hey guys. So I'll get started now. So this workshop is mostly like an introduction to data science, and you're not expected to know too much before this, but if you do know a little bit of like Python or something, then I'm sure it'll help out towards the end when I go through a Jupyter notebook, going through some of the solving like a sample data science problem. But anyways, I'll get started now, and if you have any questions, maybe you could leave them in the chat now, and I could answer them at the end. So data science is a field of study which deals with like large amounts of data and finding patterns or deriving information from it, which would help provide deeper insights. And this would obviously help in things like decision making and business decisions. And today it's data science is quite ubiquitous in terms of like the amount of businesses that use it and large companies that are using it, and how they're mining user data to gain more insights and analyze user behavior. So this is an example of what a data science pipeline could look like, which would at first step would be obviously to like collect data, and this could be done either using some APIs or web scraping, for example, or just using a different kind of data set, such as an SQL database or like a CSV file, something like that. And then the next step is usually to like perform some exploratory analysis, which means basically like understanding what the data is that you're working with exactly, and gives you like more insights into the kinds of data you're dealing with. And then you move on to visualizing the kinds of data and the different parameters involved. And then lastly, obviously, you'd maybe do some machine learning on them, for example, or you could also perform any other application of data science or AI, for example. So these are a couple of, just give me a second. One second, I'm just facing some issues with this. Yeah, so these are an example of like a couple of data science problems, which could be like numeric prediction, for example, predicting housing prices depending on the past housing prices, or depending on for example, the number of rooms in a house. So how this would essentially work is you'd be training a model based on data that you already have from the data set. So the data set would contain the housing prices and would maybe have like a couple of different parameters, like the number of rooms or how old the house is and the location of the house maybe. And then you train the model on that, and then you predict based on unseen data, which means you don't know for example, if you're selling a house on the market, you could maybe feed the input data through your algorithm, and it would give you an estimated price of it depending on the number of rooms it has, or how old it is, etc., and the amenities. And then another kind of data science problem is classification. So for example, if you're dealing with image data, this could help with a common problem that a lot of people use is like breast cancer classification, and which classifies whether a tumor is malignant or it's benign. So, and then anomaly detection, which is structured data, which is essentially pattern recognition. So for example, does like a certain group of people behave in like a similar way, or this is quite useful in terms of predicting like user behavior, and a lot of large companies today use it. And then there's anomaly detection, which could be to like check whether an airplane engine is functioning as expected, or if there's any fault with it. And then lastly, there's decision problems, which could, for example, be used in like self-driving cars, and should the car brake, or should it accelerate, should it turn left or right, and those are the kinds of problems that are there. But those are just, I'm sure there are more data science problems that exist. Those are just a couple of things that I thought are relevant today. And then for solving these data science problems, for example, like numeric prediction, you could use linear regression, which is a technique which I'll actually be presenting towards the end of the workshop and in the coding section. Or there are also like neural networks and everything. And then for classification, you could use something like logistic regression, or again, neural networks. And this might seem a little like foreign to you, and if you haven't really dealt with it before, but I'll be going through an example of a numeric prediction at the end, which would hopefully help maybe make you understand what's going on like better. And then for structuring, there's like different clustering, k-means clustering, and then for anomaly detection, there's again a bunch of other techniques. And then for decision problems, there's reinforcement learning, which is commonly used in like training autonomous robots and everything. Then, so next I'll be going on to the kinds of data that are that you would see quite commonly, which is structured data and unstructured data. So structured data could be anything that's like organized in like a predefined format. For example, like a spreadsheet or a database. And there are different kinds of structured data, like numeric data, which could be like continuous variables, for example, like the housing prices that I talked about earlier. But then there are also something called categorical data, which is usually categorical data types take one of a limited and usually like fixed number of possible values. So for example, when I mentioned like the number of rooms or locations, the number of rooms in a house would typically maybe range from like 1 to like 5, I would assume. So there isn't going to be an unlimited set of values to pick from. And this could also maybe like sex, for example, there's just male and female. And next, there's also something called time series data, which, for example, stock prices. So data that is arranged in an order of the way time moves and is not, and it's sequentially ordered. Whereas for numeric data, each column of a spreadsheet would be unrelated to the others. Whereas in time series data, each data point would be related to its previous ones. And then there's also network data, which is, for example, like social networks modeling that, or like financial transactions, for example. And then unstructured data could be basically everything but structured data, which is, for example, text or like image or voice or video. So this is an example of just a couple of data points in a data set. So over here, for example, you can see that numeric data over here would probably refer to like weight or the height, whereas the categorical would be the sex or religion or smoker or the social class as well. And usually you'd find numeric and categorical data to be part of the same data set. So it is quite common to see that as like in form of mixed data. And then usually you'd, before maybe performing any machine learning, you might, when you're visualizing the kind of data that you're going to deal with, these are just a couple of visualizations that are quite basic. But for example, a box plot would summarize the distribution of like numeric variables using boxes, and I'll be going more in depth into this in the next slide. But like a histogram, which I'm sure most of you might be familiar with, is when like the variable is cut into like several bins, and then the number of observations for each bin is represented by the height of the bar. For example, in this histogram, it represents flight delays, and in which the width of each bin is like 5 minutes. And then there's a density plot, which is a representation of like of the distribution of a numeric variable, and it's essentially shows the probability density function, and it's like a smoothed out version of a histogram, you could say. And I won't be going into depth of exactly how the math for this works, but there are a lot of like resources that you could explore if you are really interested in it. So this is a really basic visualization, and it's quite common in the data science world. So this is a box plot, and the center line represents the median of the data set, and the outer boundaries represent the lower and upper quartile, or the 25th and the 75th percentile. And then the interquartile range is the difference between the upper and lower quartiles. And the black lines outside these are the upper and lower adjacent values, which is means, for example, the upper adjacent value is calculated by like finding the highest value between the median and the median plus 1.5 times the interquartile range. And similarly, the lower adjacent is over here is the lowest value between the median and 1.5 times interquartile range subtracted from it. And then values outside of this are usually outliers. So they're either extremely high or extremely low values that that could like skew the data, or like any machine learning techniques that you'll be performing. And then, so these are a couple of libraries that you could use, and I'll be showing you a couple of them towards the end. So pandas is usually used for like data acquisition and preparing the data that you do at the beginning. And then there's NumPy, which you perform numeric computation on operating on multi-dimensional arrays. And then scikit-learn, which is a machine learning library, and it features like models for like the various techniques that I showed you before, like regression or classification, or like clustering algorithms and some other stuff as well. And then there's matplotlib, which is essentially a lower level library for like data visualizations and performing simpler visualizations. And then there's Seaborn, which is for doing more advanced data visualizations. And I've also, so these are some of the documentations for the libraries. And if you really want to know more about them, you could check them out. And so correlation coefficient is essentially shows you how correlated the two variables could be. So for example, I'll take the housing prices example again, where so maybe the number of rooms, how correlated is it with the price of the house? So if you want to find that, it's the covariance divided by the product of the standard deviations of each variable. So if the correlation is a 1, then it implies that there's a perfect positive correlation, which means if the housing price increases, then if the number of rooms increases, then the housing price also increases at all times. Whereas the perfect negative correlation is the exact opposite. So if the number of rooms increase, then the housing price would decrease. Whereas like if the correlation is 0, it means that the variables don't really depend on each other. So it's usually a value between -1 and 1. I mean, not usually, it's always a value between -1 and 1. And this is a correlation matrix, which I'll be showing you later when we start coding. And then below that is like a graph of, for example, two variables having a perfect positive correlation, and then a high positive correlation, and then a lower but positive correlation. And then as you can see, the two variables that aren't correlated at all are just randomly dispersed. And then a negative correlation is the exact opposite. And yeah, so there's also bivariate visualizations, which I'll also show you later. But for example, joint plots, which are commonly used, is used to visualize the relationship between two variables while describing their individual distributions as well in the same plot. So there's also it's essentially a combination of like a histogram and a scatter plot. But you could also use univariate plots like box plots to independently compare the different variables, like these over here. So now we could I'll be going through like a Jupyter notebook where I'll be showing you some of the techniques, and essentially I'd attempt at solving like a sample data science problem. And so Asta has sent a link in the chat, which should I think, yeah, it leads you to the data set that we'll be using. And could you also send the link to the notebook, Asta?
Yeah, just
Okay. Okay, yeah. So if you click on the link, it'll lead you to a notebook, which is a copy of this that I'll be going through. So if you can upload the file by clicking on the left and then um, dragging and dropping the data set into it. So this environment is Google Colab, which is like a shared or online version of a Jupyter notebook, which essentially allows you to execute blocks of code rather than the entire thing. So that's what a lot of people that's commonly used in data science these days, and I'll just be going through one of them. So at the beginning, so pandas and seaborn and matplotlib is what we'll be working with today for a data acquisition and then preparing a data as well as visualizing. And we'll also be using scikit-learn, which I'll be importing towards the end for the machine learning at the end. So you can execute like blocks of code independently of each other, which is quite convenient. And so, for example, so pandas has this method called read CSV, which allows you to read in a CSV file by just giving the name of it. And then the head method shows you like the first 5 rows of the data set, but you can also, for example, display more rows, or you can tweak the way it does display by changing the values of any arguments or passing in any parameters, which you could definitely check out in the documentation of it. And then, so this shows you like the data set that we're dealing with. So it's basically an e-commerce data set. So it contains like the email and address, and these are mostly just fake emails and addresses. So you don't have to worry about any privacy issues and anything. And then apart from that, it shows you the average session length, or like the time spent on the e-commerce app, and the time spent on the website, and the length of the membership, and the amount spent yearly. So towards the end, we'll be using we'll be fitting a model to predict the amount spent on a yearly basis by using the time spent on the app. So in this block of code, I print the type of data and then the shape as well. And by type, it over here is just a pandas data frame, which is it has just rows and columns, and it's similar, and it's usually easier to work with and then the shape of the data is like over here, it says 500,8, which means there are 500 different rows, and then there are 8 attributes, which is the email address, and then so on. And then in the next cell over here, what I do is I print the type of each column, which, for example, over here, the time on the app is a float value, which is a floating point decimal value, or the email address is just an object. And then apart from this, you could also obviously have like integer values and stuff. So we here, the amount, which is the yearly amount spent, which will be which will fit a model to and try predicting later on. And then the time spent on the app is what we'll be working with. So what this cell does is it creates a it takes in the time and assigns it to a a predictor, which means we'll be using the time on the app to predict the amount, which is referred to as a response variable. And then we'll be splitting them into train and test sets, which essentially means that the first 300 samples which we'll be using here would be used to train the data, and then the next 200 we'll be using to test, essentially. So this block of code splits the data set into 300 samples for training it and then 200 samples for testing it. So over here, I just print again the dimensions of the train and test sets. And I do this separately for the predictor and the response variable. So the predictor over here is the time on the app, which we'll be using to predict the response. So then over here, this is just some, okay, wait, I forgot it on the, yeah. So once you run these blocks of code, then this shows you just some features about the predictor variable. So for example, over here, count 300 means there are 300 different data points that we'll be working with, which is part of the training set of data. And then it also shows us other statistical measures like the mean of the time spent on the app, or the standard deviation, the minimum, the maximum, and then the different quartiles as well as the median. And then we similarly do that for the time and the amount. So this gives us a better idea of the kind of data that we're dealing with and gives us more insight into it as well. So in this over here, I plot a box plot of the time spent on the app. And then, so this is using the Seaborn library, which is we refer to as SD, as we mentioned at the top when we imported it. So we plot the box plot, and the orient H is essentially you change the orientation of it to horizontal, and then data is equal to time underscore train, where we the data that it's plotting is the train set of time. And similarly, we do that even for the amount. So again, this just gives us like a better idea of the kind of data that we'll be dealing with. And so now I basically create a joint data frame by concatenating both variables. So this helps us plot like a correlation heat map over here, which tells us how correlated both variables are and whether the time spent on the app really is a good indicator of the amount spent by the customer as well. So yeah, this is done using pandas as well. And you could definitely learn more about it by reading the documentation, and it's quite, it's extensively detailed, and it's quite easy to understand as well. And then now again, we use, so we plot the heat map for it. And so it says, so this shows us that the correlation coefficient of the time and the yearly amount spent is like 0.5, which means they're positively correlated, but they don't represent very high of a correlation, but they're still definitely related. So that would imply that maybe that you could use like the time on an app to potentially predict the amount spent yearly. So now we'll be importing the linear regression model using from the scikit-learn library. So this is where like the machine learning that example that we'll be solving here is. So this is, so over here, linreg just refers to the linear regression object that we created in the first set. And again, this is linreg.fit. So you're fitting the model based on the training data of time and then the training data of amount. So an amount is like the y coordinate and the training is the x essentially. So so we're going to plot a line which is over here. It's like the amount is equal to a times the time plus b, which is similar to like the equation of a line y is equal to mx plus c, where the intercept is a and the coefficient b of the regression line. So this just gives you the intercept and coefficient. And then if we really try plotting it out, this is what it could potentially look like, where this is the model fit this kind of line based on these data points. So so over here, that's what we did. So reg line y is takes in the intercept and the coefficient and refers to the equation of the line. And then when we actually try plotting the line, we use matplotlib's function. So we create a figure, and then this refers to the dimensions of the figure. And then this is a scatter plot of the training set of time and then amount. So it plots those, and then you plot the line itself, which over here that you created, and then plt.show would just display it. And then now if you over here, this cell does this basically plots the line again, but rather than plotting a continuous line, it plots different data points that are being used. So for example, if you look at any red dot towards towards the end of the beginning, where they're more spread out, it shows you the prediction of it corresponding to the actual value, where the red one is what your model would predict, and the blue one refers to the actual value that's present in the training set. So this is just one of many problems that you could solve using like data science that I've presented. And if you're really not familiar with Python or any other object-oriented language before, then it might have been a little hard for you to follow along. But I was hoping this would just give you some more insight into what solving a data science problem could look like. And honestly, if you do put in some time into maybe reading the documentation, it wouldn't be hard for you to work on a data science project yourself. And I do feel like working on a data science project yourself is like one of the best ways to get started with data science. And honestly, that's what I did at the beginning as well. And so if you have any like questions, you can let me know, and then I'll try answering them. And Asta has also sent you a link to the attendance form, so you can fill that in as well. So what we did over there was just solving one of the problems, which is like numeric prediction that and we use linear regression. So there are other kinds of ways to solve a problem as well. So for example, something called exponential regression as well, which wouldn't necessarily just fit like a straight line, but it does get more complex. And then apart from that, there are obviously the other kinds of data science problems as well that you could solve. And this is probably one of the most like basic ways of solving a numeric prediction problem, which is fitting like a straight line to it. And it's probably and it's a great way to get started, I would say. But if you do have any questions, just let me know. You can leave them in the chat and I'll try answering them. Okay, so if you don't have any questions, okay. So so similarly over here, what we did was we used some structured data over here to a second, let me just the slides again. Yeah, so here we just used some structured data, which is structured numeric data. But apart from this, you could also use like categorical data, which you could use some categorical data in conjunction with the numeric data. So for example, you could use in this case, you would be able to use not just the time spent on the app, but you could also use, for example, if there's an other argument, whether if the user is like for example, a prime member or like a premium customer, then that would be categorical data type. So, and that's usually when you use multiple variables, you'd be performing like multivariate regression. But in this case, we just used a single variable, and which is why it was univariate. And you could check out the notebook as well. There's a link to it that Asta has shared if you want to read more into it. And then if you have any questions, you can let me know as well. And apart from that, so for example, for unstructured data, when there's like image, voice, like video, for image, you could even use the different techniques like image classification. Like I previously mentioned, you could use it, for example, when it comes to classifying breast cancer tumors. And then again, this is audio data, which is very similar to like what your voice assistant and like your that your mobile phone might use to for like speech recognition and so on. And it's very like interconnected with data science and AI as well. And the data set that we used over here was just a standard CSV file that I found online. But the more complex data acquisition techniques might refer to like web scraping, for example, scraping data from the web, or like you could also extract data from like any APIs or any open source APIs that might be used today. And so those are just some ways for data acquisition. And what I presented to you in my notebook was a much simpler version. So over here, I just use like a CSV file, a simple CSV file. But usually when you extract data, for example, using any other techniques, and you don't have any, and the data isn't well structured, you might need to perform some data manipulation techniques and like get the data to what you want it to be. And then you'd do some exploratory analysis on your data. And then you again visualize the data, which is similar to what we did here. Boxplot, we plotted some box plots, but more complex plots exist as well that could give you different kinds of information about the data that you're dealing with. And then finally, after that, we moved on to machine learning part as well, and before that, we tried determining the correlation coefficient of both variables, which shows you how correlated they are exactly. So the higher the correlation, or the closer to 1 or -1, means they are quite related. But whereas if you look at the correlation coefficient of any other variable and it's might be much lower, then it will tell you that maybe it's not a good indicator of predicting the value that you'd like to predict. So then lastly, again, I'm just going through the notebook again in case I might have skipped some parts that I went a bit fast. So then we did linear regression, which is using just one variable that we used, which is the time spent on the app, on the mobile app. And then we fit the linear regression model to the data. And then we just plotted the regression lines towards the end using the libraries like matplotlib. So Lakshya has a question. What exactly data dim is? So that's the dimensions of it. So for example, if I go to like the dimensions of it, so data dim is the dimensions of value, which basically tells you the amount of values there is. So for example, 300,1 would refer to is like a single column of 300 different data points. So is that what you meant, Lakshya? Okay, thank you. So if anyone else has any questions, maybe you could leave them in the chat. Again, there's like a link to the notebook in the chat that Asa shared. And there's a Google Drive link to the data set itself. So you can maybe go through the notebook and let me know if you have any questions. And this is obviously just like it's a lot of information to digest in a small amount of time. So I hope that this serves mainly as like a stepping stone to maybe helping you explore more data science, and maybe you'd start working on projects yourself that if you'd like to. So it's just the last like 15 minutes of the workshop. So if you have any questions, just let me know. And then and you can read more about like the different kinds of models that are available, like the scikit-learn library by looking at the documentation a bit. Okay. So if I want to learn, if I want to start learning data science by doing some projects, what are some beginner projects that you would recommend? So this is a website called Kaggle, which you could maybe check it out. It has a bunch of data sets to some common data science problems, right? But for example, one such project could be like what I just showed you, like for example, an e-commerce, working on an e-commerce data set, which over here, and we just did some basic machine learning. But if you do want to work on it as like a project and you put more time into it, you could obviously do a lot more analysis. And for example, you could also compare the different kinds of variables acting as predictors. So what you could do is, for example, housing prices. You could maybe use like certain indicators like the age of the house, and then the location of the house, which are categorical variables, right? So if you use them in conjunction with your with like the number of bedrooms, so you can perform like multivariate regression, and you could basically analyze which variables are really good at predicting what you'd like to predict. But so, for example, housing prices prediction could be a project idea. But if you want to do something with time series data, you could definitely work on like stock price prediction. And there are data sets for that available on Kaggle as well, which Asta has sent a link to. I really do recommend it. Or if honestly, if you want to like learn more, there's also a bunch of repositories on like GitHub. And I think that's one really good way to get started. Just by looking at the code, you'd get an idea of what exactly goes into working on such a project, and hopefully you'd maybe work on one yourself. And if you do enjoy working on the projects that you worked on, you could consider like an internship or a full-time role as a data scientist, which also pays quite well here in Singapore. And a bunch of the big companies have tons of openings for them. Yeah. And if you want, there's also some image classification projects that you could work on, like for example, handwriting recognition, some common topics. But you could, when you say beginner project ideas, I mean, it's your ideas, right? So if there is an open source data set for it, and if the data is there, then you could definitely work on it. So for example, like Kaggle, which is a really good place to look at different kinds of data sets that are available. So you could use those data sets which are available to you to use for free, and you could perform similar kinds of exploratory analysis, and then that help you know more about the data, and you could apply machine learning techniques on them, and to help you practice and improve your skills in data science. And we'll be ending the session in a couple of minutes. So if you have any questions, you can share them now. Okay, thanks, Phil. I hope people had questions. I hope you answered them well, and I hope you guys enjoyed the workshop. Well, so thank you for joining today, and yeah, have a good day. You can feel free to leave now.